Welcome to everyone. Today we are going to discussing about another important topic on computer network, which is path vector routing. So in this session we are going to discussing about what is path vector routing and what is BGP, which is Border Gateway Protocol. So while we discussing about these previous sessions, we discussing about this multiple protocols we discussing about in the previous sessions. So those are helpful to the network layer. So in the network layer, how the information is transmitted in the form of this packet, and at the same time information is transmitted through some kind of routing mechanism. We have to follow some kind of routing mechanism that we calling as the routing algorithms. So in the routing algorithms, we have multiple routing algorithms are there. So based upon the techniques, based upon the mechanism we are using, that one we have to choose the routing algorithms only. So in the previous session we discussing about this distance vector routing, right? So similarly we discussing about this OSPF, Open System Path Vector. So here we discussing about distance vector path value as well as the OSPF path. In this we discussing about is a RIP, the information protocol, routing information protocol. So same way we are going discussing about this another two important protocol which we calling as a path vector routing and a broader gateway protocol. Right. So what is meant by this path vector routing and how it is useful for us, and where we are using this path vector routing. So path vector routing protocol, which means it has to provide information about each and every network. For example, we having as this particular path is there, particular network architecture is there. So in this network architecture, we having as a 5 routers are there, A1, A3, A4, A5 and A2. Similarly, we having as n number of routers are present in the same network, we allocating as a one network values only. Similarly, we having as another network values only. So the path vector routing, which means it has to save information, it has to give the information. So how we are able to reach to a network, or which means, so for example, we having this n number of routers are there. So we have to share the information from one network to another network, which means AS1 to AS2, which means one network to another network. How we are able to share the information, how we are able to reach the information. So based upon that one, we have to design this path vector routing. So which means path vector routing, which means it provides information about how we are able to reach the network or a certain routers to identify a autonomous system, which we calling as AS1, which we indicated the values. So it is similar to the BGP value. So there is a path vector routing protocol. So here we see this one. Here one A1, one subnet system, one autonomous system is connected to another autonomous system, which means A1 is connected to B1. So we have to choose this path values only. So what about this linkage between the one network system to another network system, one autonomous system 1 to autonomous system 2. So this also very similar to our BGP protocol, which means we have to maintain the autonomous system. That should be end of the system values only. So here the source information of transmitted from one network situation to a receiver or destination of another network system. So that kind of information we have to provide, that one that we calling as a path vector routing. And path vector routing protocol, which is similar to our BGP protocol, we have to maintain the autonomous system, which in order to reach the destination values only. But what is meant by this autonomous system? So in the types of autonomous system, basically it has to classify 3 types. One is stub autonomous system, multi-home autonomous system, as well as a transient autonomous system. So what is meant by this autonomous system? While seeing the previous figure, they're having as one kind of a individual architecture is there, we calling as a autonomous system 1. So this autonomous system much considerable is n number of routers, router 5, router 10, router n number of routers are present in this autonomous system. But in this autonomous system, one router is plays a vital role, which is connected to the another network system. So this is this A value and this B value, this is also a router, but this has a plays a vital role to establish the information transmission from one network to another network, that we calling as autonomous system. In this autonomous system, we having as a 3 types are there. So what is sub autonomous system? So when you see this one, in this one we having as AS1 is there, as well as we having as a AS2 is there. So information is transmitted as well as information is received. So but here in the AS1, it may acting as a source or a sink value, which means there's one is transmitted, another is acting as a receiver. One is source, another is acting as a destination. But if this system, this AS1 acting as a source, here the data momentum from this one autonomous system to another autonomous system, data momentum from this one network path to another network path values only. So here this AS1 acting as the source system, so data get consumed in AS1 which is coming from AS2, but data will not moving forward from AS1. So here any kind of autonomous system is there, so this acting as a source, this acting as my transmitter, so which means data is consumed in AS1, in which data is coming from AS1, but data will not move forward to even forward from AS1 system values only. So here data will not forwarded, so data is momentum between these values only but not forwarded in the system, that we calling as a sub autonomous system. And similarly multi-home autonomous system, when you see here n number of source systems are there. In the previous one we have was one AS1 and one AS2 is there, between the information is transmitted and received, but here we having as n number of autonomous system is there, we calling as a multi-homer system, which means a multiple autonomous systems are present in this loop. So in this source system, in this autonomous system, we having as a more than one connection, we calling as a one to many connections are there. So but they still acting as a source or sink for data traffic. So having a single source is there, but we have to give as a multiple connections are there, we calling as a one to many connection system is established between this multi-homer system. So here there is no transient data traffic flow, which means data can be passed from one autonomous system, data can be transmitted or passed from one autonomous system, that we calling as a multi-home autonomous system. And similarly the other system we calling as a transient autonomous system. The most of the real applications we are choosing this a transient autonomous system. So why in the sense, when you see this one here, one AS1 is there, at a time we can able to transfer information to AS2, AS3, AS4 as well as AS5. Here multiple autonomous systems are interlinked over there. So here any kind of autonomous system, which means any kind of data, any kind of data transfer should be occurring, any kind of data transfer traffic flow should be happening, it has to provide a transient traffic flow, because when we go for this multi-home autonomous systems or a trans-autonomous system, that is also similar one, but here one to many communications are there, at a time we can able to transmit data information, it has to provide a transient kind of data traffic flow. That is a very advantage of this a multi-home and transient autonomous system. But while coming to this BGP, the BGP, which means a broader gateway protocol, so it has to classify as a two categories. One is internal one, other one is external. So what is mean this internal and what is mean this external? What is mean this internal? We have to give the internal communication. So when go for this internal communication systems are connected each other, so that part we calling as a internal communication system. But here within the network, within the internal region, who are the systems are present, we can able to share the information, we can able to exchange information between the routers inside the autonomous system. In short, the routing information exchanged who are present in the same autonomous system. So for example, we having as one kind of LAN connection we established. With help of this LAN connection, we established one kind of intercom connection. So what is intercom connections? Who are present in the within the network region, we can able to share the information in the intercom region values only. So we can't able to share the information outside the network. So that we calling as a internal BGP system. But another system we calling as external BGP system, which means who are the systems, which means number of systems are present over there. We can able to share the information to outside the network or a different kinds of autonomous system. We can able to communicate with each other. That we calling as a external. So what is mean by this internal? Internal in the sense, what are the systems, what are routers present in the network, we can able to share the information within the network. But in the external, we can able to share the information outside the network as well. That we calling as a external BGP session. But how we are able to establish that one? What kind of types of packet we are using that one to share the information? So basically, when we go for these types of packet, there are 4 different types of packets we are existing in the BGP protocol. One is open one, another one is update, another one is keep alive, another one is notification. So we'll come one by one. What is meant by this open system one? The open system one, which means when a router wants to create any kind of neighborhood relation, like we can able to create the establishment between the one neighborhood relation, one network to another network relation. So here that kind of sends a open packet information, which means when a router wants to create the information, router wants to share the information to the next router, so there we can establish one kind of relation, the one kind of attribute relation between them, so that we have as a open kind of packet. Once we have to open the packet situation, then we can able to create the one kind of network architecture and network communication path with the next nearby the router values only. But what is this update one? So update mechanism, which means a packet can send information. The two different cases are there. One should be either should be with the destination, which has to be addressed previously, or else we have to announce the route to the new destination. Like we can able to go for the update information. For example, if we are able to share the information to n number of routers, we have to save the information. So how we are able to save information? We have to get the information to the next router. How we are able to get the information? So here, if any routers are busy or any routers are engaged, or we already send information, so once we get the information is already sent, we withdraw the notification, withdraw the update information to destination that is we're already advised. But if we go for this a new announcement, a new kind of information transmitted, so that we are able to announce information to the new destination. But at the same time, we having as a alive situation is there. What is this alive situation? Because my packet should be still alive. My packet is ready to be sent, or the information is transmitted situation. So that kind of exchange regularly to the other resources where the packet should be alive. The packet should be alive only, the ready to transmit situation only, when we can able to send information regularly to all others system values only. That we calling as a keep alive motion, keep alive situation. At the same time, we having this other important thing which we calling as a notification. So what is this notification? Here notification nothing but we can able to send the packet, which means the information has to send the packet. The previously we discussing about acknowledgement kind of mechanism. We are discussing about two things are there. One is positive acknowledgement, and the one is we discussing about is negative acknowledgement. Same way, we have to get the notification packet is sent when router detects any kind of error condition or a close condition. For example, I can able to transfer information from one router to one network to another network. So this acting as AS1 network, this acting as another sub network, AS network. For example, this AS2 is busy with some other autonomous system, right? So AS3 is transmit information to AS2. On the time this is completely busy. In this duration, we can able to transmit information. This may get a chance of this error failure. So that because router is busy, so this may have to condition should be error failure condition, or else this connection should be discarded. So that kind of information we are getting, that we calling as a notification kind of situation. So but while we establishing this format in the packet format or message format, what kind of things we are using that one, what kind of packet structure we are using that one, so that we calling as a message format. So in the message format, total length should be 32 bits. The total length of this BGP message format, which is 32 bits. In the 32 bits, we having as one is marker should be having as a 16-byte value, and the length of the value should be 2 bytes and type should be 1 byte. So what is meant by this length and what is meant by this type? Which means the length of the information or length of the message format kind of structure we calling as which is 2 bytes. And other important thing, the type, what kind of information byte is there, that we calling as that should be 1 byte information is there. Overall the total is 32 bits values only. Overall the bit is 32 bit values only. So when you see this one, this should be the form of 32 bits and this should be the form of this byte values only based upon the information transmitted. And what are the major advantage of this BGP and what is the disadvantage of this BGP? What is BGP? A broader gateway protocol that should be a scalable information transmit. It should be a reliable kind of information, scalable kind of information, and we have to maintain some kind of granularity is possible here. So that is a major advantage of this BGP, and we have to face the issues of this count infinity. When you go for this, the distance vector value or RIP mechanism, what we discussed in the previous session, we have facing the major issues of this count to infinity, but we have to overcome that issues in this broader gateway protocol. But what is disadvantage? It should be very complex. While I am designing this protocol, the architecture structure while communicating from one network to another network while creating a sub network system, so this kind of architecture is very complex situation, because continuously we have to monitor the information transmitted to other network value. If any connection is discarded, that should be very hectic for us. The data may lose the information. So that is a very, very bigger issue in the data communication. So that we have to maintain all the things that is very complex to establish the network architecture. At the same time, we have to maintain the routes to the destination network rather than the specific host or routers. We have to maintain the destination path network values only. So that is a very, very disadvantage here. So the next one is flooding. So till now we are discussing about different kinds of routing protocols, different kind of information transmit carriers, but at the same time we have to understand the things importance of this flooding mechanism, because the information is continuously transmitted, right? Some kind of information may arrive, some kind of information may discarded or damaged. So we have to understand what is this flooding mechanism and how we are able to analyze the flooding mechanism. If any issues are getting in the flooding mechanism, how we are able to overcome that one. For example, see this example. So here, incoming call from packet 1, which is send information to packet 2 as well as packet 3. At the same time, packet 2 send information to packet 6 as well as packet 4. Similarly, the packet 4 send information to 3, 6, 5, etc. etc. So here, n number of ways to information carrier is there. So, but at the same time, all these are, we have to say the information packets within the, based upon this different routers are present over there, like A, B, C, D and E. But different kind of networks or architecture is present over there. But the information is transmitted to the sub-network, sub kind of information packet, the routers 1 to 2, 1 to 3, or as 4 may information shared to 4 to 1, 4 to 2, 4 to 3, or 4 to 6. So, some kind of different kind of path is available over there. So, where we recall, in the previous session we were discussing about this distance vector routing or the path vector routing. So, the information is transmitted from different kind of path vector. We have to analyze the shortest path. For example, information is transmitted from 1 to 2 or is 1 to 3 or is 1 to 4. We have to choose the shortest path, that one. Then only we will be able to move the information to the shortest path router values only. So, same way, here also we are following the same mechanism. But we have to choose the selector values only. The router does not take the information to every packet, because a router do not send every information packet to the every line. It may has to choose information different direction till the information reach to the destination. So that is a major advantage. So we calling as a selective flooding. What is selective flooding? For example, here information 1 is that it connected to 2, connected to 3, connected to 4, connected to 5. So in this situation, this packet does not send information to every packet values, does not information to packet 2, packet 3, packet 4, packet 5, not like that one. Here information is packet 2, we have to select the specific line which is the direction to my destination values only. We have to choose that path, that we are calling as a selective flooding mechanism. But what is selective flooding mechanism? What is advantage of this one? So in the selective flooding mechanism, we have to prescribe the selective path mechanism to reach the destination value. We have to choose the limitation of distance value. So that should be highly robust, highly reliable value. And if you go for any kind of emergency system or intermittent system, we go for this kind of flooding mechanism. Generally in the military kind of applications, space kind of applications, we are using this kind of flooding mechanism. And this is helpful in the creating as a virtual circuit mechanism. This is very, very helpful for creating a virtual circuit mechanism. And this flood always chooses the shortest path. Here you can able to say, you can able to choose the nearby destination path. At the same time, we have to choose the shortest path. That is a major advantage of this flooding mechanism. At the same time, this used for this transmit the broadcast mechanism. We have to be able to go for the broadcast messages, not a unicast message, the broadcast messages. That is very helpful for this flooding mechanism. But at the same time, we have some kind of limitations are there. We having as a huge advantages are there. At the same time, we have some kind of limitations are there. What is limitations? Because a flood generates the vast number of packet, it may chances of getting the duplicates, because n number of information transmitted, it may get the chance of this duplicate packets. At the same time, the suitable damping mechanism must be used, because assume that when we have n number of packets to transmit that one, packet 2, packet 3, multiple times receive the situation. So we can't able to decode the same 1 and 2 packets, because already we receive this 1 and 2. We simply discard it. We simply ignore the packet, because those are calling as duplicate. We have to dump in that kind of mechanism. That is an advantage. At the same time, what is this hierarchical routing? So we have to say that information transmitted, we have to follow some kind of hierarchical mechanism. But what is hierarchical mechanism? We will see, we have different routings are there, different kind of regions are there, different kind of routers are present over there. For example, region 1, A, B and C is present over there. Similarly, in the region 2, A, B, C and the presence of them. Similarly, in the region 3, region 4, region 5, it may be two routers or 3 routers or n number of routers are present over there, but information is transmitted in the hierarchy manner. So, for example, 1B transmitted to, what is distance is 1, it transmitted to C. Next one, the information C is transmitted because B to C is then transmitted to 2A. 2A to 2C or 2B next to 2D information. So, we have to follow the hierarchical manner, which means 2A may transmit information to 1B. You will see this one, 2A transmitted to 1B value. What is the length? What is the length of the value? How many hops are present? So, the 1 hop, 2 hop, 3 hop, all these things are into one kind of routing table, which we are calling as a full table of 1-year routers and hierarchical table of 1-year router. So, when you see the comparison between this one full table and hierarchical table value, we have to maintain the value 1B information sent to 1C. The distance is 1. Similarly, 1B to 1C. What is the distance? As 2. Similarly, here n number of hierarchical manner is there. Information is transmitted from 1C to 3B. Or as n number of nodal connections or n number of regional connections are there. That we are calling as a hierarchical routing. So, I conclude in this session. So, in this session, we are discussing about this important topics which we are calling as a path vector routing, as well as we are discussing about this the broader gateway protocol. So, in this discussing about what is the usage of these values and what is the advantages and what is the disadvantages or what is the limitations of values we discussed in these sessions of the protocol. At the same time, we are discussing about this hierarchical protocol as well. So, in the next session, we are going to discussing about the important topic is congestion control. So, what is congestion control and what is usage of this congestion control and what is the necessity of this congestion control we discuss in the upcoming session. Thank you.